In a video game, you can follow a sequence of levels in order to reach a goal. You move from one level to the next, with each serving a purpose and allowing you to reach the next one. In some video games, the path from level to level is sequential, and the only way to reach the next is by finishing the previous one. In other games, the flow of levels branch, with multiple options that allow the player to choose which level they will try to tackle next. When you release a game to multiple people, players participate in levels concurrently. You can have multiple people playing your game at the same time, in their own unique instance. In a UML activity diagram, you represent the control flow from one activity to another in a software system, much like you could display the flow from one level to another in a video game through a level selection menu. You can consider activities as actions that further the flow of execution in your system. They are actions that, when completed, cause another action to execute. For example, these actions can alter objects or create new objects. These changes, or actions, drive your application forward. The purpose of the activity diagram is to capture the dynamic behavior of the system, how control flows from one activity to another. The activity diagram allows you to map out the branching into alternative flows. When you are creating an activity diagram, you will first need to identify the activities. These are the actions performed by the system. Once your activities and their respective conditions have been defined, you will be able to create your activity diagram. Activity diagrams have a few major parts. The start and end nodes, denoted by labeled circles, are where you must begin your diagram. They show the starting activity that initializes the control flow of the application. The end node shows the final activity of the diagram. The intermediate activities are shaped in the same way as a pill. They describe all of the activities that change the game state before the game ends. This example shows a decision node, which has an activity leading into it and the possibility of two alternative outcomes as the next activity. The choice of outcome depends on how the condition on the decision node evaluates. In the diagram, all the essential activities must be included, as well as the conditions. Let's now look closer at this example of an activity diagram. This contains the two essential elements of an effective activity diagram, the activities and conditions. The starting point of the activity diagram is denoted by a circle, labeled by the event cause. In this case, we are starting the activity diagram by playing the game. From there, the player starts playing the level activity. Once the level is complete, the player encounters the first condition, whether or not their score is high enough to reach the bonus level. If it is, the player can play the bonus level. If not, then the player ends the game, denoted by a circle. This activity diagram covers all of the activities and conditions outlined earlier, which is essential for creating a complete diagram. You can also map out concurrent activities that happen in parallel. For example, when a player starts a level, the game's soundtrack begins playing simultaneously to the player playing the game. There is a fork in the flow into parallel flows, so activities to play the game soundtrack and play the game can happen concurrently. Parallel flows can join into a single flow. For example, as a level ends, the parallel flows to play the game and to play the game soundtrack also end and join into a single flow. One of the main ways concurrent activities are shown in an activity diagram is via partitions. Partitions divide activities up into different categories, such as where it occurs or the user role involved. For example, all of the video game activities concerning levels could be grouped in one partition, and all of the player activities could be grouped in another partition. Swim lanes are used in an activity diagram to display these partitions. Take a look at this diagram of swim lanes. There's always a label for each partition. Arrows crossing each lane show you how different activities of your system interact across the partitions. Activity diagrams allow you to map out the high-level behavior of a system. They do not care about implementation or code and merely focus on the control flow between actions. With these diagrams, you can pinpoint exactly what activities and conditions should be included, and get a better idea of the order in which features are encountered, while still taking into account alternative flows for your system.